Hello everybody, in this video we're going to talk about how we can identify some similar triangles. So definitely a geometry topic, and you'll cover this more as you progress through high school math and you get into geometry, the geometry specific course. But for now, in this pre-algebra type video, we're going to go through just some basics about how we can identify some similar triangles. So it all has to do with their angle measures, because we know similar shapes, they're shapes that are the same shape, but they may not be the same size. So when we have triangles, we know that those angle measures should still be congruent if those shapes are similar. So let's take a look. It says two angles in one triangle are congruent to two angles in another triangle. So if this is the case, then the third angles are also congruent and the triangles are similar. Because remember, the three angles inside of a triangle, the interior angles, they're going to add up, or their sum is 180 degrees. So if we have three angles total and two of them in each of our triangles are the same, then that means the third angle in each triangle must also have the same measure. And now we have two triangles that have the same three angles, therefore they would be similar. So we see an example of this here with triangles ABC and DEF. So they each have a degree of 68, or an angle of 68 degrees, 92 degrees, as well as 20 degrees. So we could say that triangle ABC is similar to triangle DEF. So notice this symbol here in the middle. It's like a squiggly line just like that. That means is similar to. So if you see that in the future, you'll know that that means similar. Later on, you might see this symbol, an equal sign with that squiggly line on top of it. That means congruent. Okay, so in that case, those shapes would be the same shape and the same size. But that's not the subject of this video. This video is about similarity. So that's why you're going to see this symbol here. Let's look at a couple examples here. We have four of them. We'll start up here with number one. So let me zoom in just a little bit so we can see those angle measures. So number one, we have two triangles. And what we're going to do on these two examples is just tell, are these triangles similar? So here we see an angle of 70 degrees on both triangles, and we see an angle of 55 degrees on both triangles. So even though we don't see this third angle measure, we know that they have the same measure, because they add up to 180 degrees, right? So if we have those two angle measures that are the same in both triangles, then we know that third angle is also congruent. So we're just going to simply say yes on number one, and that yes means that those triangles are in fact similar. Let's jump over to number two. Number two, they give us a 42 degree angle and then a 38 degree angle, okay? They're not the same, but maybe that's not the problem, because maybe we have a separate angle in the triangle that's equal to those. But if you remember, this box here indicates a 90 degree angle. So we do have two 90 degree angles, but the other pair of angles in those triangles are not the same measure. They're not congruent, which means that X and Y are not going to equal each other in this case. So we could simply say no on number two, and that means that those triangles are not similar, because all three of their angle measures would not be the same, okay? All right, let's jump down here to number three. We have a slightly different example here. We have one triangle that's kind of split into two. So it says, are triangles ABC, so ABC, and ADE similar? And we're going to use this marking here. That means, those little arrows means that those lines or those segments are parallel to each other, which can then make us think back to parallel lines and a transversal, which would tell us, okay, we have some corresponding angles here. Angle C, or angle ACB, would be the same as angle E, because they occupy the same position on those parallel lines, where this segment here would act as our transversal, okay? So we know that those two angles are the same in the triangles. They also share this angle here, right? They both have angle A, so now there's two angles in each triangle that are congruent, which means this angle here, ABC, and this angle D, let's put another arc there, those also have to be congruent. So we would say yes on number three, those triangles are similar. All right, and number four, it's a little bit of a different diagram. This is what's known as indirect measurement. So let's say, for example, you're standing across a river or some kind of body of water, and you're trying to figure out how far is it across that body of water. Well, one way to do that is to set up two right triangles by taking some measurements along the side of the water that you're already on. So let's say, for example, you're standing right here, okay, and you're trying to figure out, maybe this is your water here, and you're trying to figure out what is this distance from me to across the water. So essentially we can build a similar triangle and we can use a proportion to help us find that distance. And in this case, we're representing that distance with x. Okay, so we have two similar triangles. Well, Mr. Roper, how do we know they're similar? We don't see any of the angle measures. Well, we see that we have two 90-degree angles, so there's two angles that are congruent. And then also these angles here are what are known as vertical angles, and those are congruent as well. Okay, and then we could also use these angles here and say that those would be alternate interior or alternate exterior angles, because we do have some perpendicular lines, which then means that our 12-foot line and our line here with x would be parallel. So we could use those, and those would act as alternate interior angles. So multiple ways to figure out how our angles are congruent, which then implies that these triangles are similar. So now we can set up a proportion. Okay, let's say 10 over 12, right? 10 over 12 would be equal to 8 over x, okay? 8 over x. So now we have two ratios that are equal to each other. That's what's known as a proportion. So we can now cross multiply. So 10 times x would be 10x, and 12 times 8 is 96. Now we simply divide both sides by 10 to get that variable x by itself, and we would say that x is equal to 9.6 feet. All right, so once again, that is known as indirect measurement, and that's how we can identify some similar triangles.